Okay, so today we're going to be talking about the sine rule. And this is a very nice formula that relates the lengths in a triangle with the angles in a triangle. So what's important to know is when we are writing little a, little b, little c, these are associated to the angles, capital A, B and C, but on the opposite side of the triangle. So angle A is corresponding to length little a on the length that's opposite the angle. And the same for B. The length B is associated to the angle capital B that's opposite the triangle. So essentially this is telling us that the ratio of the lengths and the sine of the angle that's opposite that length is the same no matter which corner we choose in the triangle. So this is really useful because we can find missing lengths or missing angles in a triangle. And we're going to look at two examples, one where we have to find the missing length and one where we have to find the missing angle. So for the first example, we're going to look at this triangle. I'm going to sketch it over here. And we're told that this angle is 30 degrees, this angle is 40 degrees, and let's say this length here is 8 centimeters, and then this length is x. So this is what we need to find. So this is good because we can use this formula just like the first two terms, because we have a length that's opposite this angle, and then this length we need to find is opposite this angle, which we know. So let's just use this formula. I'm just going to write the letters here so you can see how we're going to use this. I'm going to write capital A here for this angle, and then this means this length is little a, and then if I call this capital B, this angle capital B, then this length is little b. So I'm going to use this formula with these letters. So little a is 8, so this is 8 divided by sine of capital A, which is 40 degrees. And then by this formula, it's equal to the ratio of little b, which is x, divided by capital B, sine of capital B, which is sine of 30. And now we can just solve x. So typically the hardest part of this problem is to just identify which are your variables that you want to find out. So now we can just rearrange for x. If I just multiply it by sine of 30, this gives us 8 times sine of 30 divided by sine of 40. And you can plug that into a calculator, and this comes out as roughly 6.22 centimeters. And this is the missing length of this triangle. So now we're going to do a similar example, but instead of finding the length, we need to find the missing angle. So I'm just going to rub it out and then we'll look at it. Okay, for our second example, we're going to be looking at this triangle. It doesn't really matter what the shape is, but I'll just write in the important information, which is the angles. So this one is 40 degrees now, and this one is x. So we're going to try and find out what x is, and also y. So this angle is y, we need to find out what x and y is. But we're also told the lengths of some of these sides of the triangle. So this one is 8 centimeters, and this is 12 centimeters. So if we think about using this rule, we see we have two pairs of sides and angles that we can use. So 8 centimeters is opposite the angle 40 degrees, and also this angle of x degrees is opposite the length of 12 centimeters. So we can use the formula right here to find out what x is. And then we need to find out what y is from that information. So let's just apply this rule. We want to find the angle, so we have 8 centimeters divided by this angle, sine of 40 degrees. This is equal to 12 centimeters, this length, divided by sine of the opposite angle, which is x here. So now we can just rearrange for x, and I can multiply sine of x up here and multiply sine of 40 up here, and we'll have sine of x equals 12 divided by 8 times sine of 40. So this is just rearranging, it's equivalent to this line. And then to find out what x is, we just need to invert sine. So we just need to apply the inverse of sine, which is something your calculator can do. So this is inverse of sine of this right hand side, so 12 over 8 times sine of 40. And if you plug this into your calculator, it's going to give you the approximate answer of 74.6 degrees. So this is what x is. So now that we know what x is, we need to find out the missing angle y. And in fact, we can't use the sine rule again because we don't have the missing length opposite the angle. But what we do know is we know that all the angles in a triangle, they add up to 180 degrees. And this is how we're going to find out what y is. So we know that 180 equals 40 plus x plus y. And we already know what x is, so we can just rearrange for y. So y equals 180 minus 40 minus x. And I'm just going to substitute this in, so minus 74.6 roughly. And then if you do this calculation, this is going to give us the angle y equals 65.4 degrees. And there you have it. That's an example of using the sine rule to find missing angles and missing lengths.